first, right?
Mm-hmm.
So 1 times 3, or is
Mm-hmm.
it just 3? Or
One by three, something like that.
okay. And then 2 times 1,
Mm-hmm.
and then 3 times 2.
Yeah, three times two. Three times two. There we go. Oh, yeah, three times two. Da-da-ba-dum. Those are going to be fine.
Yeah.
Let's see. I'll move this thing. To add or subtract matrices, you just add or subtract them to the each number in the corresponding matrix.
Hmm.
So they have the two matrices have to be the same size. Uh, you can also do these in the calculator. Um, you're using graphical, is it?
Yeah. Oh yeah, there is a button that says matrices, but I don't know how to use it.
Uh, I have to renew my license for this thing. That won't work. I'll try anyway. All right, I'll use simple one.
Oh, I think I did it.
Yeah.
Yeah.
So my one is 4. So I define matrix 4. 2 by 2. 2 minus 1. Wait. 0, 3. Option. Nope. Define matrix. Define matrix P. Yeah, I need to renew my graphical one.
I don't know how to add them together, but
So you might have to then just like, so in my one, I just have to find matrix A plus option matrix B,
mhm.
and then I add them that way. Um, Graphical. Is there any way for you to just like,
I think yeah, I think I got it now.
and did it work?
Hold on. I'm still doing it, but
Uh,
I I figured out how to do it though. I think it's probably easier to just do it without the calculator.
okay, it's
But
sorry.
it's just like a bit long.
I'm just kind of practicing it now because later you'll need to use the calculator for
Oh,
uh trickier stuff.
I got it. It says 1, 3, 5, 6.
And oh, did I delete it? Did I paste it? Who knows? 1356 1356. Yeah, that's it.
Yeah.
Okay, grand. That as those, you're gonna be fine there. To multiply a matrix by a scalar, you multiply every element by that scalar. And so in my one, I would do 2. It would look like that. 2 matrix A. And I would have to redefine matrix A. My
Yeah.
my matrix A is something else. Is that one okay?
Hmm.
Yep. What is part C?
They're different sizes, so you can't add them together.
Yeah, different dimensions, not the same size. Uh, okay, let's try this one. Any way you like.
Let's see. Oh, you just have to equate like each one basically.
Uh, so let's solve it. And I don't think calculator will be able to do this one.
Yeah. Could you like move the? Okay, no, that's
Uh,
my. Never mind.
okay.
This is my like screen blocking it. I got A is equal to 4,
Right?
B is equal to 3, and C is equal to 8.
8, 4, 3, 8. That is great. What do you give yourself there?
Tick.
Okay, matrix multiplication. This is multiplying two matrices by each other. It is so they have to have the same number of rows as columns, not necessarily the same size. You multiply each row by each column. So it would be for this one 5 times, or let's say what they did. This would be 8 times 2, 3 times 9, minus 4 times 7. So it works that way.
Like add them together. Right?
And you add those together, yeah.
Okay.
And you can see how like 8 times 2 plus 3 times 9 plus minus 4 times 7 give you 15.
Mm-hmm.
Yeah. And so you start with top going down. Okay, go on. Talk me through it.
So like you just multiply the row of the first one by the column of the second one. So you just do like 1 times minus 3 plus minus 2 times 2. Is that right? Or yeah, which is minus 3, yeah, and then do 3 times minus 3.
Yeah.
Plus 4 times minus 2. No, just 2. Sorry.
4 times 2.
Yeah. And that gives you minus 7 on the top.
So that gives minus 7.
And then minus 1 on the bottom.
Minus 1. So you did
You're right.
minus 7, minus 1. Minus 7, minus 1. That's it. Explain why it's not possible to do B times A.
It's because the number of rows isn't like the same as the number of columns for the other one.
Yeah. The number of rows in A is not equal to the number of columns in B.
Yeah.
And what you can also do is just get your matrix A times
matrix B.
Matrix B, and obviously mine are two different matrices. I just don't want to bother, and you can get the answer that way. I think we get the idea.
Yeah.
Just talk me through what's the working out for this one then.
So you do minus 1 times 4 plus 0 times 0.
Mm-hmm.
And then 2 times 1 plus 3 times minus 2. I'm not sure if I did this right.
That would go there then. 2 times 1 plus 3 times minus 2.
What about like both the columns? Okay. So 2 times 4.
Yeah.
Plus 3 times 0. And then minus 1 times 1.
Minus 1 times 1.
Plus 0 times minus 2.
Times minus 2. And if we simplify this...
I just remember this now.
Why, you did this before?
Yeah, I did a bit at GCSE.
It's minus 1, and then that is minus 4. That's it, I think. No. Let me check.
Yeah.
Oh, is it?
That's right.
Okay.
Yeah. It's the top one.
Let's see. Sorry. It's part A and part B, and then it's just doing it in reverse. Okay, great. Any questions there?
Not really.
Let's see. So let's practice. Oh, the size of the matrix. Let's not bother. I think you'll be okay for the size of the matrix.
No, I don't know.
Okay.
Okay.
Find the size of these matrix products. B times A.
How do you know the size?
So the quick way. Let's see. If we go to this one, then the number of. So our answer was 2 times 1.
Yeah.
So this is 2 times 1. There's a quick way. I know there is.
Oh, okay. Same number of rows as the first one and same number of columns as the second one. Okay, that makes sense.
So this one, how many rows?
2. Wait, which one? The one that's 2 times 1 or the one in the example?
The one that we did. This one down here. That's
Yeah.
why. Yeah, sorry, I was looking up here. It should be this one. So this one is 2. This one is 1 column. So it's rows times
Yeah.
columns, I believe. So this one was rows times columns. So 2 by 2. Okay. Okay.
So 2 times 2, first one.
Let's check. So A is 1 by 2. B times A, rows times columns, I believe.
Oh, rows is first. Okay, I got it now.
Okay.
The second one is 3 times 3.
So second one is 3 times 3. B is 3 times 3. Yeah. Okay.
Yeah.
C.
Um, 1 times 2.
D.
2 times 2.
Sorry. 2 times 2. E.
2 times 3.
And F.
3 times 2.
3 times 2. So we check the first two. 2 times 2. So 2, 2, 2, 3, 3, 2. Did we go? Oh, sorry. Yeah. 1, 2, 2, 2, 2, 3, 3, 2. 1, 2, 2, 2, 2, 3, 3, 2. Great. Any questions with those?
No.
Okay. So this is, yeah, comes up a lot. How about this one?
So when you multiply them, it's like minus b, right?
Yeah.
And then ab, like underneath that. Is that right?
Let's see. Row B times A. We multiply across and down, isn't it?
I'm confused.
So
I don't get the multiple one.
when we multiply, it is across, yeah, and then down. So it's like x, y, across, down. And so we do B.
Oh, so it's minus b and then 2a.
So that's going to be, is that not it for the first one? And what will be the dimension? of the answer?
2 times 1.
So,
Wait, no. 1 times 2.
so 1 times
Wait, no.
2.
2 times 2. Sorry.
So,
I think it's 2 times 2.
so it's b times minus 1. Let's see, I'm putting a plus there. So that's minus b. What's next?
AB?
Down. Yes. Am I right in saying that that's plus, though?
I don't know.
I think that's what it is. No.
But then how can it be 2 times 2
I think
if
that's what
it's
it is.
added?
Um,
Didn't have enough
is it 2 times 2?
things.
If you go across, then down, I think
Isn't
it's...
it the rows of the first ones and the column of the second one?
Yeah. 1 row, 1 column, 1 by 1, I think. So I think it's that equals
But
0.
A. Oh, B is the first one. I did not see that.
Oh, okay, yeah. Sorry. Oh, sorry. Oh, given that BA is equal to 0, find AB. We're trying to find AB. Okay, so BA is equal to 0. What is B equal to?
I'm trying to find what BA is.
So this should
But
be...
yeah, the sign is 1 times 1.
So BA is equal to 0. What
Is
is...
that BA minus? Yeah, okay.
What is B equal to?
I don't know. 2A? Wait, no, minus 2A.
2A.
Wait, no, 2A.
So
Yeah.
that was BA. Now let's do AB.
So AB is minus B and then 2A.
And so
I don't understand why it gets added. Like, you know why you wrote minus B plus 2A? Why is that added? Because you have to add them.
the way we did this one.
But there's like separate terms. I don't understand.
So 8 times 2.
Why is it not a matrix though? Because
It's
it's just minus B plus 2A. It's not like a matrix.
it's a 1 times 1 matrix.
Oh, there's only one thing.
Yeah.
Okay.
Did I go past it?
Yeah. This one.
Sorry.
So that one would be minus B and then wait, no, that was the first one.
It's the same here as well. So minus B. So it's a cross and then times down.
So it's minus B. It's the same as minus B and 2A.
So it's minus 1 times B, then minus 1 times 2.
Oh, so that's minus 2.
Mm-hmm.
And then AB and then 2A.
That is it. They wanted...
Okay. So you just, and then you just substitute B is equal to 2A. So you just do minus 2A squared. Is that right?
Mm-hmm.
Yeah, and then minus 2 and then 2A.
2A. Let's just take a look.
You just like simplify, right?
There we go. Minus 2A, 2A squared, minus 2, 2A. So they just wanted it in terms of A. So this...
The multiplication is confusing, but I think I'll get used to it.
So this first one was 1 by 1. And then this second one...
2 times 2.
2 by 2. Yeah, going across, going down. Any questions there?
Not really. It's just the multiplication, but I think I'll get used to it. It's just like a bit confusing.
Yeah, Yeah, I often forget as well. Okay. Is this worth doing?
Oh my god.
What would be the easy
So
way to do
sorry.
it?
Calculator.
So something like this you could do in the calculator. Do you want
Yeah.
to practice without calculator?
Yeah. Oh, I don't mind either.
Like, I don't mind even skipping it, and it's just good practice for.
Yeah, because the multiplication is a bit confusing, so I don't practice it.
Okay, b times c.
So that would just be. Wait. That'd be 1 times 2, like the size of the.
Rows times columns.
Yeah. Oh, 1 times 1.
Yep.
No, 2 times 1. Wait, no, 1 times 1. Sorry. I'm getting so confused. Okay. And then. Wait, so that's just one thing. So it's just 12 minus 10, which is 2.
So that's going to be 2.
Yeah.
Oh.
And then.
So then.
2a, basically.
So it's going to be 2 times by a.
When it's like that, can't you just do like 2 times a, like the scalar product?
Let's see. So it's across times going down.
Or is it?
No. So it's going to be this one and then going that way.
Isn't that the same as scalar product though?
Yeah, these are all scalar product, just numbers. No. You're correct. Scalar.
The one, yeah, one where it's like 2a or something. It's like, isn't this the same?
Yeah, 2 is a scalar in this sense.
Yeah. So 2 minus 2, 4.
Let me think about this.
Right? No?
Yep. 2 minus 2, 4. It better be. 2 minus 2, 4. Great. We practiced 2 minus 2, 4. So this is what an exam question looks like. What is this one?
What is the 2 times 2 identity matrix?
Oops. The identity matrix 0, 1, 1, 0. And so basically,
Okay.
it's like times by 1, essentially.
Oh, okay. Prove that a squared is equal to 2a plus 5i. Okay. I guess you should figure out what 2a plus 5i is. So, so 2a is just 2, 4, and then 6, and then 2 on the bottom. Yeah, like that. And 5i is 0, 5, 5, 0.
0, 5, 5, 0.
And then you just add like each one, right? So 2, 9, 11, 2. And then you have to calculate a squared.
You could calculate it if you prefer.
Yeah, I don't want to multiply that out. Doesn't look fun. Oh, 2 times 2. Seven, 4, 6, 7. That doesn't look right.
7, 4, 6.
Okay, they're weirdly not equal. I think I put it in right.
I'm sure you did. Matrix. See.
I don't know why it came out weird. Maybe I should try matrix A squared and see if it's different.
7, 4, 6, 7. Okay. 2 times. Do you know what?
So
It's probably me. It's probably 1001. That's probably what it is.
oh.
Sorry. Is it 1001? So
That would be 500. That makes sense now.
sorry, my mistake. Going by memory.
It's okay.
And does it work?
Yeah, 7, 4, 6, 4. 6, 7, sorry.
6, 7. Therefore, a squared equals 2a plus 5i. That's it. And any matrix times by the density matrix will just be itself. Any questions about that?
No.
This one looks pretty good. How about this one?
Squared in terms of x. So you actually do have to multiply it out.
Looks like it. Is it worth doing? Or you?
It's like column times row, right? Wait, no, it's across and then down,
Yeah.
right?
Yeah.
Okay. So would the size be 3 times 3?
Yeah.
For the product? Okay.
So what's this one going to be?
So 1 plus 2a. I don't know if it's plus 2a or
yeah,
plus 1.
How'd you get that?
It's just the 1 like in the top left multiplied by. Oh wait, no, it's not 1. It's C. Right? Is that where I made a mistake? Yeah. And then would the one next to it be like 2 and then minus 2? Would it be the one next to it? Or the one underneath?
So I'd do this one next and put it here.
Okay. A minus A and then 1. So it's just 1 basically.
Mm-hmm.
And then 1 AB 0.
AB.
And then 2 minus 2.
2 minus 2
Plus BC.
Hang on. What one are we doing now?
The 1, 2C row times the
minus
2 minus 1
plus BC. Yep.
and then 2A
How'd you get?
right?
What are we doing again? So we did dump.
The second row and the second column.
2A.
Plus 1 plus B.
Mm-hmm.
And then 2 minus B plus 0.
Mm-hmm.
And C plus 2 plus 0. AC minus 1 plus 0. And then C plus B plus 0.
And simplify.
Hey, that's just 1 plus 2a plus c. Can't really simplify it, but. And then 1. 1 plus ab. bc. 2a plus 1 plus b. 2 minus b. C plus 2. AC minus 1. C plus b.
Mm-hmm.
That's all you have to do, right? Yeah.
2a plus c plus 1. 1ab plus 1. bc 2a plus b plus 1. 2 minus b. 2 plus c. ac minus 1. b plus c. Great. Any questions there?
Yeah.
So that becomes important later on. Let's see. Given that. AC is that. Let's go until we solve one of these.
Okay. So we have to multiply them again. Yeah. So 1 minus a, yeah, plus b. And then a plus 2a plus 0.
Yeah. So can you now solve for a?
3a is equal to 9. A is equal to 3.
Yeah. A is 3. And then I think you'd be okay for the rest of them.
Yeah.
Oh, there's only one other. There's b, is it?
Yeah.
All right. Let's see if we can get b.
So.
Oh, actually, we should be able to get b now, shouldn't we?
Yeah. B is minus 2.
B is minus 2. Oh, that wasn't as grueling as I thought.
You didn't have to do all of them.
3 minus 2. Ooh, the book sure did. Well done. Let's see. Prove that a times b is equal to b times a. I think you'd be fine with that. Just multiply one by the other.
I'll try.
Do you want it, or you think you'd be okay?
No, it's fine.
Yeah, I think you'd be fine.
Multiplication's still a bit confusing, but like I'm getting it. But it's still like.
What is I?
Identity matrix 1, 0, 0, 1.
Yeah, for
Sorry.
the
Way around.
It's got diagonal ones going that way.
Other
than that, it's fine. So what do you give yourself for that?
Like in between the half and the tick. Yeah.
Okay, determinant. The determinant of a 2 by 2 matrix is AD minus BC. So
Yeah.
Diagonals.
Try and remember that.
Start from the top left. Okay, determinant of A.
Just 4 minus 4, which is equal to 0.
AD minus BC. What is A times D?
Oh, it's A times D. Oh, okay. 12.
Yeah.
Minus 5. Minus 5, yeah.
Uh-huh.
Which is 7.
7. Calculator. Option. I'm going to define matrix D. 2 by 2. 6. 5. 1, 2. Option. Let me see. Matrix D. Option.
If you press option and matrix, yeah, you can press determinant.
Determinant of matrix D. Option D. And we get 7, and we had 7. Any questions there?
No, it's not that hard.
Yeah, it's alright. Given that A is singular, bless you,
Thank you.
If the determinant of a matrix is 0, then it's singular.
Okay. That means 4 times 3 minus p minus 1 p plus 2 is equal to 0. Solve for p.
Just put the whole thing in the calculator, is it?
You could. I probably won't though.
Huh? I will. You can do it your way. Just want to see if it works.
Okay, I'm getting weird answers though.
What you get?
14 over 3.
Yeah, I got the same thing.
Okay.
Answer 14 over 3. And there we go, 14 over 3. Great. Yeah, determinant is equal to 0. It's singular. Okay, you didn't think it was that easy, did you? Now it's time for a 3 by 3 determinant.
Oh my God, what is this? Okay,
This,
I'm never going to remember this. Do you get the formula for this, or?
I don't know. I hope to God you do.
Yeah, I can't remember that.
Cool.
Pretty bad.
So here's how I'm going to do this one.
Calculator. Right.
Matrix 1 is 3 by 3.
Minus 25.
Yeah, I got the
Okay,
same. I got the same thing. And is this the right question?
Yep.
Ooh, the minor.
What?
Hang on.
What did you do?
No. They asked a different question first.
Okay. But it's not minus 25.
That's a different question. Hang on.
I'm confused.
Find the determinant of it. So it said find the minors.
The minors. I don't know how you find
of the elements 5 and 7. So the minors are the determinants of the little bits in there. So it's the determinants of the 2 by 2 matrix.
What do you mean by 5 and 7? Like, what do you have to do?
So for this one, so you cross out the rows and columns for 5, and so you find the determinant of that 2 by 2 matrix. For 7.
And you cross out the 7 ones, and then you do. Okay.
And
That doesn't seem that bad.
Yeah, 5, 2, minus 1, 1.
Okay.
5, 2, minus 1, 1. And they use this, it looks like a modulus symbol. It's just that means determinant for this one. Okay, let's put this in the calculator so we'll verify it.
That's right now. The calculator. Sometimes it just like does the same thing like 3 times, and I don't know why.
Okay.
$38.
I also got 38. I got 38 there, and they got 38 there. Great. So the first question was just kind of like a stepping stone type thing. Okay.
Okay. I need that formula.
Let me. This won't work, will it? Nope.
I doubt you can put that in.
Yeah, it was worth a shot. Worth a shot. Copy. Okay. That's the formula.
So 3.
So this one is going to be
3.
3.
And then 1, 2, 0. K plus 3. Like that one, the first one makes sense because it's just like the bottom corner, but the other two do not make sense.
They make plenty of sense.
Minus K.
So you put a cross on that K, and then what remains?
Oh, okay. That now makes sense. Minus 2, 5. Oh, wait, no, 2 in there. Yeah. 5, K plus 3. Plus C. Oh, plus 0. Oh, so do you have to write that one? Because it's just
nah.
at the end. There's just going to be 0 at the end, isn't it?
Yeah.
Okay. So, oh, do you find like the individual ones and then you multiply it, right?
We could do it, yeah. So 3. Do you remember what the determinant of 2 by 2 is?
Yeah, K plus 3 minus 0.
Yeah.
So 3K plus 3. Yeah. And then, wait, 3K plus 9.
Bah. You're right.
And then minus 2 minus K plus 3. Wait a minute, minus 2 times K plus 3. Minus 10. Yeah. Which I really don't want to multiply out.
Just do that bit in there first.
2K minus 16. Yeah. And then plus 2K squared plus 16K. Yay. That's it.
Simpler.
Factorize out K.
Simpler.
Oh, factorize out 3K.
No.
No.
What's 3K plus 16K?
Oh, 19K. Quadratic CA plus 9. You don't like solve it, right? Okay.
You do now, part B.
Fine. Given that A is singular. Oh, that means it's equal to 0, right? The determinant is equal to 0. Wait, why did you write B is equal to 0?
Part B. You cheat this man. Fine.
Find the possible value. Oh, so that's just solve, right? Minus a half and minus 9.
That's it. Minus 9. Hang on. Possible values of K minus a half or minus 9. Blah, blah. Minus a half or minus 9. Great. Any questions there?
No, just long.
Yeah, it kind of broke down easily enough though.
Matrix is just long. It's not that like difficult so far. It's just everything is just really long.
Given that K is a real number and that M is that find the exact values of K for which it is singular. Seems similar to what we just did, am I right?
Yeah, I think it's like the quadratic again. Yeah.
Yeah, if not easier. Because it's 2 by 2, that's fine.
Same question.
Show that it is singular.
I don't know that. Oh, because it's just 0.
Yeah, so when you...
Equal to 0.
Yes, when you do the determinant of this...
There's basically always going to be a 0 in the matrix or like being multiplied by 0, so everything is just going to be equal to 0.
Yeah. So 0 times the first matrix, then minus A times the second, and then it's minus B times the third one. So first one's obviously 0.
Yeah.
The second one works out to be ABC, and the third one works out to be ABC. Sorry, minus ABC.
Yeah.
And so
Okay.
it ends up being 0. This one is non-singular. What's this about?
It's not equal to 0 ever.
How do you know?
That's what non-singular means.
When is it quadratic?
B squared minus 4AC is less than 0. No real roots.
0, therefore no real roots, and then therefore...
Wait, that's the determinant as well. Why do they give things the same name?
It's
Isn't that called determinant as well?
Well, it would be like if we did this one. So it's going to be very similar to the one we just did. Except at the... Like, what is B squared minus 4AC for this one?
19 squared minus 72.
72. Greater than, equal to, or less than 0?
Greater than.
Greater than 0, and therefore two distinct real roots. And so for that one, it'll just be a B squared minus 4AC will be less than 0.
Yeah. I was just saying the matrix thing, the determinant, and isn't like that B squared minus 4AC formula is also called the determinant, I think.
Yeah, you're right, actually, isn't it?
It's really confusing.
Yeah,
Yeah,
I forget that one. This one, same idea. I think you'd be fine.
Yeah.
And turns out it's a cubic at the end. And it's got 3 roots of m. Given the determinant of n is find. Is this worth doing?
I think it's just multiple parts, but
looks similar. Looks okay. The determinant for this one, okay, can turn to b is 2. These are very similar. Yeah.
as long as you use that long formula, yeah, I get determinants.
That one is not inverse. So if m is a, b, c, d, then the inverse of m is 1 over the determinant of m times, and you swap the diagonals and swap the signs of the right side. Sorry, swap the diagonals for these.
Just swap the sign. Okay.
And swap the signs.
I'm trying to remember this, but there's a lot of things to remember.
I can't remember that. Malarkey.
Yeah, there's just a lot to remember. Wait, you have to figure out whether it's singular first. Yeah, singular, would it not have an inverse? Because it would just be like 0.
Because you'd have 1 divided by 0, which you can't do. So I'd calculate these.
The first one has, it is not singular.
So that's non-singular.
And the second one is, so we didn't do that one. And the second one, the third one is not. Yeah.
Okay. Inverse.
A. So 1. A. Sorry, I'm doing A. So
A inverse. Oops. 1 over.
Oh, okay. I was just saying the matrix, but 1 over determinant of A.
What's the determinant of A?
3 times 1 minus 2 times minus 1. So 1 over 3 minus, just 5. Wait, how was, that was part of it. I thought it was like 1 over determinant m is equal to that bracket. I didn't realize that was a part of it. Okay.
It's times it.
I'm confused now. 1 minus 2, 1, 3.
That's it. And inverse of C.
Okay. So 1 over 1 times 0
Mm-hmm.
minus 3 times 2, so it's just minus 6. And then the inverse 0 minus 3 minus 2, 1.
Looks good. Minus 6, 0, minus 3, minus 2, 1. And here they actually expanded it, like they multiplied it by the scalar, but whichever way you prefer. B inverse cannot be found, and then that one was there. Any questions about that?
No.
There's a good reason for these. You can express simultaneous equations as matrices. So you know how you have like ax plus by is equal to c, dx plus ey is equal to f, that type of thing.
Yeah.
And so you have something like let's say a, b, c, d, and then that's times by xy or whatever, and that gives you your like answer. Your xy would be this times the inverse of ABCD. That's just off the top of my head. You come to that later, but that's what this inverse is very good for. It's especially good for if you have a 3x3 simultaneous equations or 4x4. You can just in one go get the inverse, and then that gets you all the answers. How do we do this?
Prove. Okay. I have no idea.
Let's see.
Like A, B, C, D. Like you just make them equal to something random, right?
No, I think if so PQ minus 1, I think that's the same as QP to the 1.
Isn't it the reciprocal? So it'd be 1 over PQ to the 1. So it's just 1 over PQ.
I don't remember. So
Then if
PQ.
there's negative, you have to do like the reciprocal.
I don't remember this.
I don't know what this is.
Okay. If we have to, we have to. Let's see. A, B are non-singular. 2 by 2 matrices. B times A is prove that. Maybe we do need to do this proven malarkey. Hang on.
Oh, I think I got that one.
Okay.
You just divide by b squared, or like bb, and then you get I over bb, and then that's just b to the minus 1 after, because it's like the reciprocal.
Okay.
I think, but I don't know how to prove it.
What about question B?
I'm the matrix A. Oh well, it gives you what b is, so you square it first.
No.
No, I don't know how to do this.
Hang on, let's just before we do this. This is prove that given that A, I just wanted to show that A equals D. Just wanted to do, for which values of K does it have an inverse? Yeah, let's try this.
So you don't want to be equal to 0. You don't want the determinant to be equal to 0.
It's not equal to 0, yeah.
Yeah. So minus 2, then times, wait, no. Yeah. Minus 3k.
Minus 2 minus 3k.
Equal to 0, and then it's everything else.
Yeah.
Yeah.
And
So minus 2 is equal to 3k.
yeah,
And then is equal to minus 2/3.
it's minus 2/3. And so
K is not equal to minus 2/3.
yeah.
Yeah.
So k is not equal to minus 2/3. And then b.
Find n minus 1. That's the inverse. So that's 1 over minus 2/3, which is minus 3/2.
Hang on.
Wait, no, the determinant is minus 2 minus 3k.
Yes. So 1 over
Minus
minus 2
3.
minus 3k.
And then you just do the inverse, which is minus 1.
Yeah.
Minus 3. Minus k. 1.
No.
Oh, 2.
Yeah. And it is non-singular.
So
Find
equal to 0.
I think no.
That is find m minus 1 in terms of k, right?
I think that's just it. So
Yeah.
they just got rid of the minuses, but
Yeah.
cleaned it up. That's it.
Right.
Any questions there?
No.
Okay, so that was let's see, a inverse, and then a plus a inverse. It's all right. Determinant, and then determinant. Find the values of k. It's all right. A inverse again, so 1 over the determinant, and then yeah, and then doesn't exist, so that one just make it equal to 0.
Yeah.
Solve it. I think it's a quadratic and you get 2 values. Yeah, there you go. Yes, inverting a 2 by 2 matrix.
Yes, I understand it.
So the only stuff we didn't get to was inverting a 3 by 3 matrix.
Mm.
And that's, you know, particularly good for like solving 3 by 3 simultaneous equations, that type of thing, which is what you would do after you do that. So solving 2 by 2 simultaneous equations, it would be overkill to use this method.
Yeah,
but
the method is easier.
3 by 3 it gets, you know, makes more sense. How is that for you, Amogha?
It's good.
So anything in particular you want to do next time? We can finish this stuff or something else.
Let's just finish it.
Okay. We got 100 out of 150.
Okay.
Any questions for me in general?
No.
All right. Well done, Amogha. You did great. I look forward to talking to you again next week.
Bye.
Have a good week. Goodbye.